Hi, hello everyone. This is Kavita from St. Joseph College of Engineering. I work as an assistant professor in the Department of Information Technology. What we are going to see today is a very simple machine learning project where we incorporate the basic fundamental steps in it and a very simple basic machine learning project so that you can excel if you know it clearly, and if you want to add an advanced concept to it, excelling in the basic fundamental concept is very important. Now, to start off with the machine learning projects, we need to have two things, like what is the tool I'm going to work for it, and what are the data which is required to do any process. Now, say for an example, I want to find whether a patient is going to have diabetes or not. And if such a patient is going to be examined for whatever he is going to be, we need to have data for it. So obviously, to start up with any machine learning project, we need to have a data set. So once you are very familiar with what is your problem statement, you need to gather up like what is the most and fundamental thing of collecting your data set. So to start up with, we need to have two important criteria to start your process. The first thing is like I need to know what is the tool I'm going to work for it, and the second one is the datas for related to my problem statement. So to be start up with, I'm going to take Anaconda Navigator, where inside it you'll be having a jubilee of tools. Like say for example, we got data spell, we have a Jupyter lab, Jupyter notebook, we have a PowerShell prompt, PyCharm, then I have a Spider, data load, deep note, and all. So among all this, the most prominent way to work on with any machine learning project is, or machine learning deep learning project is Jupyter Notebook. See, why we go with a Jupyter Notebook is it is a very interactive computing notebook where you can edit, run, debug your codes, and also after completing all this, you can able to do a data analysis inside it. So if I can use up with my Spider, when I opt my Spider, it can also do a basic fundamental thing, but it is a very powerful Python IDE. Now inside Python IDE, you can do your editing, interactive testing, debugging and all. Now for our purpose to get some interactive graphs and to do a data analysis, we are going on with Jupyter Notebook. You can able to see Jupyter Notebook here. Now once you click on this launch button, it will automatically start up with, and to be with, I have clicked already. So when you move on with the process, this would be the first screen that is been appearing for you. Now inside this you will be having many folders, and also you can able to see a drop down called new. Now once you click on this new button, you can able to see Python IPY kernel files. Now these are all called as notebooks. Now when I click on this particular Python 3 IPY file, it will create a notebook. And inside this notebook, we are going to write some code inside it for our problem statement. Now say for example, if you are moving on with the process, we are going to do some project inside it. Now before we are doing any project, we need to save our file, correct? So go on to file, automatically you can click on the save file, and I'm going to click it as a sample ML file. ML stands for machine learning, ML project file, okay? ML project file. Now after that I'm giving save, and here you can able to see two things. One is save as, the other one is save and checkpoint. What is the meaning of checkpoint is, see, working in real time, you will not be writing any single line of a code, correct? You will be having multiple lines of code where you need to keep a checkpoint and verify whether any escalation happens to it. And that particular time, you are going to particular checkpoint and you verify whether that particular escalation is being correctly rectified or not. So I'm not saying like all the real-time process is being viewed up with Jupyter, but it is also very important. Usually in testing, we used to keep a checkpoint to identify whether the actual result and the predicted result are equal. So if you want to identify those, you need to have several checkpoints in your code. Now to incorporate that feature, we have both, like you can save the whole file as a notebook, and also you can save it as a checkpoint also. So for my sake, I have taken checkpoint save. Now once you have taken the checkpoint save, inside this Jupyter notebook, we have some 4 types of things you can include in your whole tech notebook. The first thing is called as code, the second one is markdown, third one is raw, NBA, convert, and the last one is called heading. Code is, as you all know, it is going to be Python code. So if you start writing the Python, if you want to start writing the Python code, you can click on this Python. What is markdown is, suppose in between the code you want to write some notes regarding all those, and like you want to take some sticky points of a note, you can have those marked down. What is raw NBA convert is, your entire notebook can be converted into a raw data. And what you call as a heading is nothing but a title with the different sizes and all, and you can include all those titles like whatever your need is. So say for example, let me start off with a markdown, because this is an initial stage. I used to write some of our notes and all. So when you start off with markdown, now let us say what we are going to do is, we are going to do some sample machine learning project. Now inside the sample machine learning project, what is my problem statement is, I want to find whether, say for an example, whether a person is having diabetes or not. So let me call that particular person as a patient. So I'm checking whether the person is having diabetes or not. We used to call that as a D, right? What stands for D is whether the patient or whether a person who is coming for a checkup is having some features of diabetes, or is he going to have some diabetes or not. This is what we are going to find out. See, inside machine learning, if you are doing any machine learning project, I initially told you like 2 things are very important. One is the tool, the other one is the data set. So for doing up this process, I have taken up the diabetic prediction data set. So when, let me open up this data set and show you like what are all the fields that is being used. Now you can able to see different columns with the different data, correct? So it is around 1 lakh rows of data we have, and I do have 1, 2, 3, 4, 5, 6, and 7 columns of data. The other one, the column says age, hypertension, whether the particular patient is having a heart disease or not, then what is his BMI, then what is his HbA1c level, then what is his blood glucose level, and based upon all this, we are going to predict whether that particular patient is a diabetic patient or not. Okay. Now, in machine learning, if what all those columns are called is, the first, I should say 1, 2, 3, 4, 6. The first 6 columns are said to be called as inputs. So we usually call this as a data. The first 6 column is usually called as an input. The last column is called as a label or an outcome, which means if these particular 6 columns are being with some features or feature level, and I'm going to describe that particular patient as a diabetic patient. If they are going to be above or below certain level, we are going to categorize them as a diabetic patient or a not a diabetic patient. So I'm telling you clearly once again, the first 6 columns are representing data. The last one represents the outcome or a label. Now, we usually call or we usually categorize the machine learning, the learning process into 3 ways. One we call as supervised learning, the other one is unsupervised learning, and one more we have is reinforcement learning. So what is the meaning of supervised learning is, if you do have this last outcome column, that belongs to a category called supervised learning. And in some cases, this last column won't be available, which means what? Like the outcome column will not be available. When the outcome column is not being available, we just categorize that into an unsupervised learning. So we have some set of steps for unsupervised learning to make it as a supervised learning. So to initially start up with, we are going to work upon with supervised, which means what? We are going to have input and also the outcome column. Okay. Now, to start up and begin with, let us say what are all the stages, or let us say what are all the phases we have in the machine learning project. So what are all the stages we have in the machine learning project is machine learning project. So first one, initially, you need to understand what is the problem statement. I need to be very clear about what is the problem statement. You need to have about the domain knowledge. What are all the independent values? What are all the dependent data that is being required for the process? It is important. Once you are very comfortable with the domain knowledge, then you can able to proceed on to the next step, which is called as data collection. So usually the data is being collected from various forms. Working in a real-time project, if you are not collecting the data collection properly, if you are not doing the data collection properly, and with an improper data, if you are doing your project, then the final evaluation will not be close as to what your expectation is. So what happens is you have to go back to the data collection state once again, then you have to redo it once again. So usually it will take around 6 to 8 months to do a proper data collection. So doing a proper work in the data collection process is very, very important. Now, how can you do this data collection processes? Usually you can, normal thing is you can do data being collected through forms, and you can ask for the domain experts help also. Now, if the domain experts helps are like they are more familiar with the process, so they'll be able to help you with the data or the process where you can able to collect. Now, once you've been collecting all those, you can able to do a data repository where this data repository is being correctly performed. Now, once after you do data collection, the third step is data wrangling. What is the meaning of data wrangling is you need to cleanse your data, or it is also being called as data cleaning. What is the meaning of data cleaning? In the sense, whatever data you collect, it will not be in a structured format. Obviously, it is going to be in some unstructured format. So obviously, we all know that we used to collect data in the form of an Excel or .csv files. And these CSV files, we cannot able to give 100% assurance is very clear all the time. It is very cleansed all the time. So in that particular case, what we have to do is we need to identify what are all the things that are making the data unclean. So you need to identify that, and you have to perform some sort of a process to clear it. So this data cleaning itself is a very big topic. It is like you have series of 4 or 5 steps to be followed to verify whether the data is being properly cleansed or not. Now, once after you do data cleansing, I'm making my machine to understand like these are all the proper data for my problem statement. For that particular problem statement, you work for it. Now, the fourth step is you have to do EDA data analysis. So what is the meaning of EDA data analysis is, it is exploratory data analysis where I'm able to analyze my data in the form of a graphs. So what is the meaning of graph is like, for example, whatever data set we have taken to verify whether the person is having diabetes or not, whatever we have taken, I have taken around 1 lakh row of information. So to just see that 1 lakh rows of information as a layman, it will be more confusing for me, correct? So it is obviously for everyone to need to understand it properly, we need to have some graphical information like the PowerPoint presentations we made with the graphs and information. We do exploratory data analysis with the graphs so that I can able to get the points very clearly. Now, after you do all this, then I'm going to do something called as feature engineering. I have to say it is feature engineering. So what is the meaning of feature engineering is, I'm going to identify whether my data is it is an influential one. What is the meaning of influential one is, say for example, I want to find whether I want to find a place in Chennai, so that that particular area is being with the features I have been thinking of. So for this particular scenario, the area component or the area column in the data set is very important, correct? So due to some data cleansing process, if you are able, or if you want to, or if you did clear that particular column, what happens is a very influential data is being missed out, or a very influential data is being deleted by you. So what is the meaning of feature engineering is, are you having all the influential data for your problem statement properly? Am I having all the influential data for my problem statement, so that I can able to do a very good prediction as an output for a new given input? That is what is called as your feature engineering. Next, the sixth step is called as testing. The fifth step, I should call that as training and testing. So even doing all this feature engineering, all the correction, all the data cleansing process, once you do all this, you have to make sure that some sort of a data is being used for training, and some sort of a test data is used for testing. So usually in real time or in companies, they do call this as Pareto analysis, where you have 80% of a data is being used for training and the 20 is being used for testing. Or else you can able to go for 70, 30, 60, 40. So the percentage would be like whatever data that is being used, that should be high in the form of a training. When you do more data with the training, you can able to make your machine learn a new feature which is going to come back again. So the sixth step is going to be training and testing. Now once you do all this, once you do this thing, then I need to identify which model is going to be the best suitable model for my project. So there are so many models, like I already told you in the beginning, we have different types of learning, like supervised, unsupervised and all. So under unsupervised we have different sort of a process, and supervised we have something called as regressions and classification. So inside regression and classification we have so many different models. So based upon your process, based upon the training and the testing, I am going to decode what is the model that is being needed. So what is the model that is being needed for me for my next process? So once you understand, like, okay, this is the model I need for my project, then you can able to trigger up. Next, the eighth step is going to be the evaluation. I could say evaluation. What is the meaning of evaluation is, definitely you are going to have some metrics. So metrics, in a sense, it is a numerical quantity, correct? So when a numerical quantity comes up, you are going to have some metrics to analyze the model. So say for an example, if I'm going for any regression type of a model, I could say, like, I will be verifying my accuracy score. I will be verifying with my accuracy score. Then moving on with the classification, I will be using on my confusion matrix to find it. So for each and every model, there is an evaluation metric. This evaluation metric is used to do the analysis, like whether I have done my process correctly or not. Now the next step is like tuning. So what is the meaning of tuning? What I do with tuning is, once you do all this process, once you write coding for all this process file has to be changed into .pkl files. So what is the meaning of .pkl files is, those are logic files. These logic files are created from Python pickle module. So what is the primary module or primary motto of developing a machine learning project is that you have to create a .pkl file. So When a machine learning what is it when a when a person works on a machine learning project, what is the ultimate goal is he will be building up the final logic files, and these logic files will be given to the developers, and like they will, the person who is working on front and back end, they will be connecting all those. And then if they want to create some mobile based application or an artificial bot, they will connect this .pkl file with the process, and obviously when you give an input, it is going to start your prediction for the output. Now inside this data cleaning or data wrangling phase, we have some series of steps or series of things to be taken care of. So let us discuss about the few things that has to be taken care in the phases of data cleaning. The first thing to be noted is you need to verify whether your project or whether your data set is having any null data. Meaning, if you are going to have some around 1 lakh information inside your Excel file or .csv file, there would be a chance that some of the field would be empty. So you need to find whether you have any null data or not. The second thing to be noted is you need to verify whether you have any duplicate data. Meaning, in a sense, like if you are going to have multiple number of duplicate data, it means that you are not going to end up with the same good prediction in the final. Then the third thing is you need to do something called as label encoding. What is the meaning of label encoding is when I'm going to have data in the .csv file, I cannot give you 100% assurance that all my information will be of numerical data. And you have to be very familiar, or you have to be very clear that any machine learning project we work, all the data has to be in numerical format. The machine can understand only the numerical data. So suppose if you are going to have some text information, you need to convert the text information into a numerical data. So this process of some conversion, like whatever text information is there, you're going to convert that, right? That process is called as label encoding. Label encoding is a very important feature in the data cleansing stage. So once you do all this process, I told you already, we will be analyzing for the feature engineering, which I told in the fifth step. So what is meaning of feature engineering? I told us you need to identify whether the particular data is an influential data or not. If you feel like that particular data is not influential, you can able to drop it. You can either drop it, or you can either, we call dropping as deleting. So if your data is not influential, if your data is not useful, you can able to drop it. Now what is the most important, the final most important thing is you need to handle the outliners. So what is the meaning of outliner is, say for an example, I do in testing, we have something called as boundary value analysis, and we have something called as equivalential partitioning. So what is equivalence partitioning and what is boundary value analysis is, when you do a testing, if I do have a set of a data, you need to verify whether all my testing condition works properly for all the values which is being inside the partition. That is called as equivalence partitioning. And in some cases, we do identify on the boundary of your partition, sometimes it does not works properly. So you need to verify for the boundaries also. So which means what is, I need to verify for the boundary, and I need to verify whether the data inside my partition is also working fine. Now what happens in the case of outliners is, what is the meaning of outliner is, suppose consider this is my boundary, and whatever data you are having inside is this one, and whatever feature I am looking for is beyond the boundary. It's like away from the boundary, but it is also an important feature. Now in that cases, say for an example, you have a value here, and that particular value is called as outliners. So even though it is away from the boundary, I still need it, right? Yeah, I still need it because I need to do a proper prediction for my process. So in that particular case, we are going to identify whether this outliner is needed or not. If you do need that outliner, what I'm going to do, and if I don't need that outliner, what I'm going to do. That is what is going to happen in handling the outliner. So what are the stages we have in the machine learning? Basic machine learning project is first you need to know what is your problem statement properly. Then you collect the data, do the pre-processing with the data cleansing. Then you identify then you do a data analysis with the graph. The most important thing is you have to do the feature engineering, where you are going to find whether the data is influential or not. Then you are going to split up your data into training data, the other one is the testing data. Then the next thing is you are going to identify whether my model has been, what sort of a model I can use for my project. Then once you execute that model, you are going to do some evaluation with the metrics associated with the model. So it will give, see, if I say metrics, it is a numerical quantity. So at the end, I'm going to get a numerical quantity, whether my project is working to an extent of prediction or not, like the expected prediction or not. Then finally tuning, where you are going to build .pkl file, which is the logic file. So as I told you already, in real time, this particular pkl files will be given to your developer, where that will be developed with the mobile app application or whatever it is being needed for the requirement. So these are all the steps, basic steps. Now shall we start up with the coding process for it?